Good afternoon, and thank you all for being here. Welcome to our June 2025 installment of ENERCALC Office Hours. If you've been with us before for office hours in the past, you know the drill. If you're just joining us this month, we have a few quick housekeeping items to get through before we begin today's program. So, before we get going on the main body of our presentation today, I just want to start with a quick sound check. If you direct your attention to the bottom menu of the Zoom window in your browser or desktop app, you'll see the chat tool. We also have the reaction emoji down there. If you're able to hear me right now, just go ahead and throw a thumbs up emoji in the chat, give us a reaction, something like that. Perfect. Thank you guys for confirming that. And then before we get on to the rest of our introductions and stuff, I also want to do a sound check and a visual check for our primary speaker. Mac is going to go ahead and share his screen at this time. And then once again, if you can hear Mac's voice and see his screen here in just a moment, again, go ahead and give us a reaction, a thumbs up, or something like that. Go ahead, Mac.
Hi, everyone, and welcome to another office hours session.
Perfect. All right. So everyone should be able to see Mac's screen now. Now that we have our tech checks out of the way, we'll just go ahead and disable the chat. We'll move on to some introductions and get going with today's program. So, as most of you know, my name is Seth Roseworm. I'm a senior structural engineer and software developer here at ENERCALC. Our presenter for ENERCALC Office Hours monthly program is Mac Elterhony. Mac is a senior structural engineer here at ENERCALC, and he kind of splits his time between providing technical training for ENERCALC customers, working with the ENERCALC engineering team on the specs and technical behavior of our software, and then also helping maintain a presence for ENERCALC at national and regional events throughout the industry. Mac is also the founder and managing principal of Elta Design Group, which is a specialty structural engineering firm based in Oklahoma City. He's been an ENERCALC customer and user himself for about a decade, so he has a lot of great insight about the needs of our customers. For anybody who's new here this month, the Office Hours program is meant to provide simple, direct communication between us and our users, and we do several things as part of that. We showcase a lot of new features, let you know what's going on in the ENERCALC program month over month as we roll updates. We show optimized design workflows. We answer questions that are submitted via writing if people ask questions in advance. We also do open live Q&A with the audience every month. And if there's ever a question that's too involved or requires deeper digging and research, that's often going to be a better fit for our support team as they can dig in, investigate your concerns, look under the hood, and provide more detailed answers to those deeper questions. As a minor point of order, you will notice that everybody's microphones are muted. That's just to make sure that we don't get any echo or feedback during the presentation. As I mentioned, we do have open Q&A at the end of every session, and that'll be the case today as well. To submit a question for today's Q&A, just use the Q&A dialog in the lower dashboard of your Zoom window. And if you experience audio problems at any point during the session, you can simply refresh your browser or jump out and rejoin the session. If you ever want to watch today's Office Hours program or you want to share that content with someone on your team, the recordings are always posted to the Office Hours playlist on our ENERCALC YouTube channel. And you can find those through the Office Hours page on our website or directly through our YouTube channel. And with that, I will go ahead and hand it over to Mac to get going on our program for today.
All right, thank you, Seth. Okay, so we have here, I want to welcome everybody to another session of our monthly office hours program. As Seth said, my name is Mac Eltarhouni, and I am excited to be presenting to you today about the soldier pile retaining wall module from the ENERCALC's library of diverse and extensive modules. So I'd like to start our session with a brief overview of the overall agenda. So today we will be covering ENERCALC latest build, PDH announcement, what's new in ENERCALC, soldier pile retaining wall module, and how to register for office hours so you are not notified in the future. And at the end, we will have a live Q&A portion. So please feel free to drop your questions in the Q&A form throughout the presentation. So first, would like to encourage you all to check your software and make sure that you are on the latest and greatest build of ENERCALC. So if you check the top portion of your software, you'll be able to tell which build you are currently on. We do release monthly updates, and we want to make sure that all of our users are taking advantage of the newest features and program capabilities. We commonly receive support questions from our users where they note maybe an issue or a glitch, and typically a lot of times their issues are resolved just by updating to the latest build of ENERCALC. So with that being said, the current build of ENERCALC as of today is 2025-06-05. So moving on here to update ENERCALC, if you're on an older build, to update ENERCALC, you just click on this button right here in the upper ribbon. Once you click on this update button, this will open this window for you, and you have multiple options here. You can check for updates, or you can launch by clicking on this option. You can launch the For Our Users page that then you can download the latest build from there. Once you click on it, it'll automatically take you to the website, to our ENERCALC website, and it says here the software downloads and install instructions. If you jump to the second one, this is click to download the Build 20 updater. So this will just, once you click on it and you download it, this will update the build of ENERCALC that you already have on your computer. So again, if you would like the software, the program to automatically check for updates at program startup, you just need to make sure that you check this option. So every time you open ENERCALC, and if there is a new release or a new update, it will notify you and ask you if you want to update at that time. And a quick note we have here about this is that for our users who are on build 2023-08-30 to 2024-02-28, the feature to notify you of the availability of new updates does not function properly. And to fix this issue, all you'd have to do is you'd have to perform a one-time manual update, either from inside of ENERCALC or through the website, just like how we talked about it, where you go and you click on this button right here, which will take you to the website. So that would be a one-time manual update that you'll have to perform. And once you do that, then in the future, every time there's a new release, you will be notified about it at program startup. And again, we do have monthly updates where we, fix bugs, do enhancements, and add new features every month to make sure that all of the operations are going smooth for all of our users. And again, the current build is 2025-06-05, and that's the June 5th edition. If you prefer to be notified of the latest ENERCALC updates by email, you can scan this QR code or go to enercalc.com/update-emails. And this way, you fill in your information, and every time now there's a new update of ENERCALC, you will receive an email notification saying that there's something new, and you should go and update ENERCALC. Moving on, starting the last office hour session that was held in May, we started offering 0.5 PDH to the attendees, and this represents the guaranteed technical portion of the presentation. The name we use in the certificate is the name that you use to enter the Zoom session. So today when you entered, you had to fill in a name. So we use that name to generate the certificate. So in the future, if you have if you have a specific way of how you want your name to be printed in a certificate, then it would be a good idea to just write that name the way that you want it to be printed, and then in about a week or so after the session, you will receive a link to download the certificate for the session. Next here, I want to, if you have not been on the latest build, or maybe you haven't had time to look around on what changed in ENERCALC recently or what the updates are, we want to highlight some of the new features that we've added over the past few months that we want to make sure that all of our users are taking advantage of. So first, we want to talk about the decoupling of the IBC and the ASCE editions. Some jurisdictions started mixing and matching design standards. So, for example, a jurisdiction might be on the IBC 2015 code, which references ASCE 710. However, that particular jurisdiction wants to jump ahead and says and use ASCE 716 or maybe even ASCE 722. So this mixing and matching of design standards and IBC versions has created a little bit of an issue as far as calculation documentations. So previously, what ENERCALC used to do is that once you click or once you pick the IBC code, it uses whatever design standards that being referenced in the IBC. So if you are on IBC again 2015, ENERCALC would automatically use ASCE 710 because this whole thing is a one package. And now what we did after this decoupling, we are providing the option for the user and give them a little bit more flexibility to pick an IBC edition that does not match with the ASCE edition. So simply, you can use IBC 2018 and you can mix and match that with an ASCE 722. Again, this gives the user the flexibility they need to meet their local jurisdiction's requirements in terms of documentation and design criteria. The second update that's been going on now, it's been implemented for a few months, is that we have created 3 new tabs, and these 3 new tabs are addressing the ASCE 722 implementation. So you have noticed that we added these tabs right here. There's the seismic loads tab, and we added a few calculations here, such as the seismic base shear and seismic demands on non-structural components. Moving on, the next tab is the wind loads tab, and we added calculation modules for ASCE 722 wind forces per chapter 27, chapter 28, and chapter 30. And of course, you have an ASCE 722 wind enclosure classification calculator. And of course, the last tab is the other loads tab. And this one houses the snow loads module, and the same thing here with the live load reduction module. The next update we have is the native load linking, and that is completely native within ENERCALC, and it has been an exciting feature with rapid development. For those who do not know, load linking is an ENERCALC native feature that gives the user the ability to automatically link reactions from one calculation to another, and the ability to change something in one member and have the effects of that change trickle down to all the supporting members downstream. So currently, ENERCALC native load linking is available in steel beams, wood beams, steel columns, and wood columns, with more integrations into other modules already underway, and we're actively working on integrating more and more of these modules, and especially actively working on two-way operability. So you can link a wood beam to steel beam, and then you can turn around and link a steel beam to a wood beam. So you have this two-way street type of communications. In the last month's office hours session, we did a full example and a walkthrough of how to use load linking to link reactions from beams to columns. And this is for both wood and steel materials, because we had a wood beam linking into a steel column, and then we had a steel beam linking into a a steel column, and then we're doing the opposite here: wood beam into a wood column, and a steel beam into a wood column. So this kind of gives you that a good example, a good walkthrough of the two-way operability and how to actually use this in real life examples. You can watch a recording of last month's session by going to our website, enercalc.com/office hours. And then you can scroll down. You will be able to find the ENERCALC office hours recordings. And as you go down, you'll find the 2025. And then if you scroll down a little bit more, you'll find the sessions from 2024. And again, last month's session was held on May 14th, and it's titled Pole Footing Embedded into or in Soil. That was the module that we discussed last time. But if you jump to minute 13, 35, you will be able to find this example, and we go through great details and step by step of how to use ENERCALC's native load linking feature to do all of this work seamlessly. Overall, load linking is a powerful tool that allows the engineers to create a well-connected chain of calculations while minimizing the risk of transcription errors. If you'd like more information about load linking, and if the video or the example that we did last month, if you watched that and that wasn't enough, please check out the load linking playlist on that we have here on YouTube. So this playlist will walk you through how to use load linking, again, step by step, but it will go through so much more details because the example discusses how to link, a beam to a column and all of that. But what the playlist does, it actually goes through every option that's available at the user's disposal to figure out how to use load linking and how to implement that into the various scenarios that engineers face every day. So you should definitely be, you should start leveraging this powerful tool as soon as you can. We also created, additional tutorial videos, video playlists that are posted on our YouTube channel. These playlists are easy to digest and provide, again, step-by-step information on how to use some of ENERCALC modules. And we have split these into smaller videos, 4 or 5 minute segments that give you plenty of information. So please check those out for more information. Another update we have here, and this is starting in March of this year, the IBC 2024 is supported as a governing code option within ENERCALC. We will continue supporting previous IBC codes all the way to 2015. And this hopefully gives our users enough, as much flexibility as possible to be in compliance with their local jurisdictions. As we know, many jurisdictions haven't caught up to the newer editions of the IBC. So to update your project to use IBC 2024, all you have to do is go to General, then go to Building Code Information, and then from the Project Manager, select IBC 2024, and you can click Save and Close. Or instead of kind of going about it the roundabout way, you can just look at the very top ribbon that you have in ENERCALC, click on this button right here that says Building Code and Load Combinations. Once you click on that, that will bring you to this project manager page right here, and you can just click IBC 24 or whatever you want, and then you click Save and Close. Now, if you want to change ENERCALC to use IBC 2024, or honestly any IBC, but for this example, IBC 2024, to be used for all of your future projects as a default code. So you want it to be, that's the starting code that it uses, unless otherwise, manually changed. If that's what you want to do, then all you have to do is go to the top left corner of ENERCALC, click on Settings, and from the drop-down menu, click on Default Governing Code in ASCE 7 Edition. Once you click on this pop-up window will appear, and this will allow you to do two things. choose the IBC that you want to use for all of your new projects, and that pretty much becomes your default value for the code or your default selection. So we choose IBC 2024, and then you have the ability to choose a default ASCE 7 edition, 715, 716 or 722 or whatever you would like. So once you make the selection that you want to use for all of your future projects, then you click on select, and that will save and close, and all of your future projects moving forward will use those default values. Another item I want to highlight is ENERCALC for Revit. ENERCALC for Revit is a Revit plugin that allows you to design structural members fully within Revit without having to export information to another calculation software. It is a simple point-and-click workflow that allows you to design a member, obviously in a fraction of the time that it would take you, to do this process otherwise. Because all you have to do is just click on the member, and from within from within Revit, and it will automatically grab a lot of the information that you otherwise would have to input manually. Information such as, the tributary width, the length of the member, the actual size, if you have any loads assigned to it. For columns, for example, it would know you can assign a K factor for it. You can assign the in-fixity conditions. It will know how to grab the load from a beam and link it directly into your column. So it does plenty of the work that typically is done manually, and it takes all of that guesswork out of it. And of course, there are prompts, guided prompts that you can walk through and kind of pick the different values that you need. So again, it's the process is quite simple, straightforward, and it's really that easy. So currently, EFR supports the design of steel beams and steel composite beams, wood beams, steel columns, and of course foundations. So all of our users have a full gravity load path that they can use for their for their projects. And of course, much more development is already underway. So while on the topic of ENERCALC for Revit, it's worth noting that Autodesk already released Revit 2026 back in April. And I want to make sure that everybody understands that we here at ENERCALC, we do our best to stay active and up to date with the Revit editions. And we know our users rely on our software for their daily engineering calculations. So ENERCALC is never the bottleneck of their production. Hence, we issue these monthly updates, but more importantly, from ENERCALC for Revit perspective, we are compatible with the latest and greatest versions of Revit, which is Revit 2026. Another update is the ability to export tabular detailed results from ENERCALC to a CSV file. This is very useful to many engineers, especially the engineers who'd like to post-process some of the results outside of ENERCALC, maybe in their own spreadsheet or their own in-house tool. So all you need to do is go to the results that you are interested in. So for example, the ASD shear moments and all of the intermediate values, for example, that's where we at. We want the detailed results, ASD shear moments, and we want all of these intermediate values. All you have to do is just right-click and click on Save to CSV, and that will download it to your computer. You can export the results to CSV in all of our modules, and that includes, columns, beams, slender walls, shear walls, foundations, and all of the analysis modules, and wind load, seismic, all of that is already implemented. And by popular demand, we made an important update this month to the general footing module. Our users now have the option to specify top reinforcement in the footing for those cases where the footing experiences tension at the top rather than the typical case of tension being at the bottom of the footing. So you can specify the rebar size and quantity for the top layer, and you can do it separately for each direction. So now our users can specify, of course, the bottom layer in both directions, the Z and the X, and then the same thing for the top layer, they can control the X direction separately from the Z direction for maximum flexibility and maximum control. So the next table here, this table right here, that's a snippet from ENERCALC. So this is the new option. So if you are using the latest and greatest build of ENERCALC, the one that was released last week, you'll have this option. You can continue about your business as normal, which is just using the bottom reinforcement. But if you want to do top reinforcement, you click here, and that will display these new options that you have here at the bottom, and you can input whatever information you need here. And the next table right here, this table shows the results from the results tab on the very right-hand side. ENERCALC now notes if the tension is at the top or the bottom to help you navigate your steel sizes, your rebar sizes, and all of that. So you can see here the Z fluxure, for example, that creates bottom tension. Z fluxure negative create bottom tension, and then this portion right here in the Z fluxure minus X or negative X, you have top tension right here and so forth. So this examines everything in both directions. With every new update to ENERCALC, we send out release notes to outline what changed and what got updated and what got fixed. So this gives you a quick idea about the top changes, so you can take advantage of the new features and know what certain bugs got fixed and all of that stuff. So to access these notes, you can just simply click on the update button right here, and then you can subscribe to new build email updates, and that will let you know about all of these changes. And the email would actually look like this snippet here on the right-hand side. You will get a highlight of the major changes. And then at the very bottom right here, for example, it's saying that there were total 15 enhancements. Obviously, the email doesn't mention all of them, just mentions the top 3 or 4. And then the total enhancement that took place were 15. And you can click on this link to see everything. And of course, once you click on the link, it'll take you to our website, and it will show you, for example, this is the general footing top reinforcement update. This happened right here, and it's noted in the email. But for example, there's a new update that took place in the 2D frame module. That wasn't mentioned in the email, but if you go and you want to look at it, it says, okay, we're clarified the sign convention used on member and forces. So this is a good thing to have here to have an idea of what changed and what the updates are and all of that. Moving on, the focus of our session today is the design of the soldier pile retaining wall module. By just kind of using ENERCALC to do that. And there's a quick overview here of the capabilities and features of the soldier pile retaining wall module. So you can perform analysis and design to check the embedment strength and deflection of steel piles using various AISC sections. Allows the design with or without tiebacks. You can have up to 3 tiebacks. And then design both driven steel piles and the ability to design concrete encased steel piles. The next thing that it also does is that it calculates lateral earth pressures with the option to use either the Rankine method or the equivalent fluid pressure method. And lastly, of course, dynamic 2D sketches for visual confirmation of the overall construction assembly. So to start the soldier pile retaining wall module calculation, we'll follow the same familiar process to start any module. You click on the Add button, and then from this, from the various categories here, we want to click on the Earth Retention tap, and then you click on the soldier pile retaining wall module. And once you do that, we again start in the same similar fashion that we use in all of our modules. We work our way through the taps from the left to the right side, and of course we start at the general tap. So we'll give this calculation a name. That's the first thing you should always do. In this case, SPRW1, that's soldier pile retaining wall, but it's mouthful to say, so most likely I'll be saying SPRW in the future for the rest of the presentation. So that is just a name, and then you pick your steel design methodology, and in this case we're using ASD. I'm a big fan of ASD design, but you can do LRFD if that's what you like. And then we have the pile section that we want to use. I will be using a W12 by 30. That's what I'm starting with. However, if you click on this button right here with the three dots, that will display a window with the AISC steel database. You can choose whatever edition you want to use, and you have multiple section types that you can use. You can use W section, HP, or you can use an HSS section, for example. Again, I'll be using a W section for this example, which is the W12 by 30. And then we need to input the height of the soil that is being retained. So this is a sketch right here of what the construction assembly would look like, and this is the retained soil height that we're looking for. So that is 15 feet in this example. Moving on to the next section, and that is the tiebacks. So you can select none, and that means there's no tiebacks at all. This means your steel is just cantilevering all the way up. And if for our example, we want to use a tieback. So ENERCALC allows the user to have up to 3 tiebacks, and the user will have to input the location of each tieback relative to the top of the retained soil. So it's relative to this point. This is the 0 point, and everything is below it. So with that said, this is what it would look like if we picked 3, for example. Then these will appear to us. Tieback 1, let's say at 3 feet from the top. Tieback 2 is at 6 feet from the top, and tieback 3 is 11 feet from the top. So ENERCALC will have a 2D dynamic sketch on the right hand side, and that dynamic sketch will show, will reflect this information right here. So with that said, we can go back to the to our original plan, which is to use just one tieback at 3 feet from the top. So moving on to the next section, the first portion here is that if you want the base of the pile to be assumed as pinned or fixed, for right now we're going to use this to be pinned. And of course, this option doesn't show up unless you have a tieback here. If you don't have a tieback, then this is, the decision has already been made. But if you have a tieback, then now you have the option, without compromising stability of the structure or of the pile, you have the option to do pin or fixed. So with that, so after the next point that we want to do after going here and choosing this to be pinned is that we have to specify the pile spacing. 6 to 10 feet is typical, and in this example, we are going to be using 8 feet. So that's the spacing of the piles. Another important item is the multiplier for the passive pressure wedge to account for the arching action of the soil around the pile. So this multiplier, which is this one right here, this helps you with the passive pressure. That's what it really does. It helps engage more of the soil in passive pressure. So the higher the multiplier, the more soil engaged in passive pressure calculations, meaning that you, of course, will get more help to resist the demand. This multiplier is something that you typically get from the geotechnical reports. In this example, we're just going to go ahead and use 2.5, so 2.5. And of course, this is a W section, so we're using 50 KSI for FY, but if you're using a different section, just make sure that you're using the proper yield strength for the steel that you're using. And then now we have here two options. This item right here, this is pile is encased in concrete. You really have two options, the option to say yes or no. So pile is encased in concrete or not? This is the question. So if it's not encased in concrete, then all we need to worry about is the pile flange width. So that's the flange width of the steel member that you are using. And that flange width, in this case, is 6.52. That is brought automatically because we already chose, a W12 by 30. That's what the pile or the section flange width is. So ENERCALC brought it here automatically for you. However, this is not locked. So you can go ahead and say, okay, well, I want a flange width of 8 feet or, 8 inches or 9 inches or whatever. Maybe you're doing some sort of a reinforcement or an additional plate or something. If you're doing extra stuff, you have the ability to override this number. And instead of using the actual flange width of the W12 by 30, you can use a user inputted flange width. So that is option number one, which is pile is not encased in concrete. The answer is no here. Now, if the answer was yes, so pile is encased in concrete, you can see here that you're getting a whole different input here. So if you go back, there is nothing here, and then you have the pile flange width. However, if you say yes, the pile flange width will go away, or the input for it will go away, and now you have diameter of encasement. So the user needs to input a diameter of encasement. ENERCALC displays a useful note regarding what that minimum diameter of encasement must be. This will then be used for the passive pressure calculations to help resist the demand. And you can see right here, it tells you a little bit that this is, the square root of the depth square plus the flange width square plus 6 inches. And then, this is based on a 3-inch cover, concrete cover. That's what's assumed here. So the bottom line is that it gives you some information so you can have a good idea of how to choose that minimum diameter of encasement. So in this example, we are just using the steel by itself, so no encasement in concrete. Finally, we enter, this is the last piece of the puzzle here, which is the total pile embedment. We are saying that we're embedding this 8 feet into the soil. And that is just, again, a guess, a starting point. The last portion we have here under the general tab is the unbraced length for the steel pile. So the user needs to pick from one of these three options. Option number one is to consider the steel pile to be completely unbraced for lateral torsional buckling considerations. So you're saying that's completely unbraced, you have nothing that's bracing you. Second thing is consider the pile to be braced at tie-back locations, which of course will reduce the unbraced length for lateral torsional buckling. And the last piece of, or the last option we have is consider the pile to be fully braced for lateral torsional buckling. For this one, I'm just gonna, for the example, I'm gonna choose the first option, saying that the whole pile is completely unbraced. Don't worry about the tie back, bracing it. Don't worry about this. Just use, move forward with this, considering this being completely unbraced for LTB. Now we're finally ready to move on to the next step, which is the lateral earth pressure. If we have no tiebacks at all, then the user has the option to use either the Rankine or the equivalent fluid pressure methods. So if you click on the Rankine method, which is this one, this option right here, what happens is that you have to populate a few input, some information here. So the first thing that it asks is is the phi, the soil angle here, and we're going to assume it's 30 degrees. Then it asks you for the soil density. We're using 120 PCF. You could use 110. You can use whatever the GTEC report provides. And then we want to include a surcharge on top of the soil at the retained side. I'm putting 15 PSF surcharge, and I am noting that we have a backfill slope of 20 degrees. So ENERCALC then will auto calculate the passive pressure, which comes out to be 360 PCF right here. If then it then allows you the option, and that's what I want to emphasize here. When this calculation right here, this happens, based on your angle and based on the Rankine equations, and it automatically calculates the passive pressure, and then it allows you the opportunity to use a safety factor to the passive pressure. Maybe you say I want to use a safety factor of 2 or whatever. For this example, I'm just using 1. I'm not worried about it. So then again, it auto calculates the allowable passive pressure, which of course is the same number. And it gives you here an opportunity to neglect a particular height of the soil from the top. Most of the time we neglect, the top 12 inches of soil, saying, that's just a topsoil that doesn't contribute to the structural stability. We want to ignore it. So then you get to ignore it right here. Alternatively, if you didn't choose the Rankine method and you decided to use the equivalent fluid pressure method, then you don't have to put an angle anymore, but what you have to input is the equivalent fluid pressure. In this case, we're using 35 PCF. Again, the soil density is the same. The surcharge and the backfill slope are the same. But now the passive pressure is something that you have to input. It's not going to get automatically calculated. This is a user input now. And then you'll find yourself in the same boat with the safety factor. And then, of course, the allowable is always automatically calculated based on what the passive pressure is and what the safety factor is. And then, of course, neglect this height of passive pressure at top. That's the amount of soil you want to neglect. So this remains the same. So what's important to say here is that all of this is applicable only if you are not using any tiebacks. If you're using tiebacks, then ENERCALC calculates the pressure a bit differently, because now you have a whole different profile. This is not your regular standard calculation process. So for tiebacks, whenever you have that, this is documented here under the soil pressure reference tab on the right-hand side. This shows you how ENERCALC handles the calculations based on having just one tieback, which is this right here, or having multiple tiebacks. So going through the calculations of that and the equilibrium, this is really the formula that you end up with for a magnitude for the P, that's the magnitude of the pressure diagram, the pressure in the diagram. So now that we have addressed all of the input information, we are ready to visually evaluate the final assembly as well as evaluating, of course, the results. If you click on the construction tab, which is right here, if you click on the construction tab, you will have this this 2D sketch. This shows you the slope of the soil, which is shown here at 20 degrees. It shows the location of the tieback, which is at 3 feet from the top. And of course, it shows the required embedment. Right now, it shows it as 7.41. We told it that to have, 8 feet worth of embedment. It shows that right here. It says extra embedment provided, which is 0.59. You can choose to further optimize the design, or you can just say, okay, this is good enough. I'm going to keep it at 8%, at 8 feet. And under the wall loading tab, you will have this different diagram that shows you a little bit more of the reaction here at the at the tieback. And in this case, the reaction is 41.4 kips. And the reaction at the base, which is 13 roughly 13.2 kips at the bottom. That's the base reaction. So now we can finally look into some numbers, which is now we're looking at the summary of the results. I want to start with the same numbers that we just saw in the diagrams. So you can see that the required embedment is 7.41, and this already includes the 1 foot of the ignored pressure. So the actual embedment that you need is 6.4, but we know that we have 1 foot that we're ignoring at the top. Hence, that gets added. So 6.4 plus 1 is 7.4. And then you look here at the reactions, tieback 1, 2, and 3. Since 2 and 3 are zeros, we don't have those at all. So there's 0 displayed for the reactions. And of course, tieback number 1, the reaction is shown as 41.4 kips. And the base reaction is shown as 13.195 or 13.2 2 kips. And that's the base reaction. Additionally, here we have a lot of information to go through to help you make a good assessment regarding the stability and regarding your design. You can see here the moment and shears are displayed, maximum moment, maximum shear in the pile, and they're shown for both ASD and LRFD, so service and factored values. And then below it right here, we show the deflection, which is, you have the extreme deflection, that's your maximum deflection, and the location of the maximum deflection, as well as the deflection at the top of the pile. So all of that information is displayed right here. Lastly, you can review the design status. It clearly shows that the steel section, this is design status right here. It says okay or not okay. In this case, everything is okay. And it clearly shows that it's the steel, the first part, the moment capacity is okay. However, you're looking at, 0.99 ratio. So we're looking at 99% capacity. So, this is an engineering decision. If you have the tolerance, you can just use that and be happy with it, or maybe you want to bump up the size a little bit, or do something different to bring this number, this ratio, stress ratio down a little bit. Next, we have the shear capacity, which is the status is okay, and of course it's at 0.47, so 47%. That's pretty good. And finally, here we have the embedment required. The status of that is also okay, so that means the embedment that we provided is good and acceptable. So based on this, a W12 by 30 with an embedment of 8 feet into the soil and a single tieback located 3 feet from the top of the retained soil is, that is simply is an acceptable shoring system. So ENERCALC, this is important here for everyone to know, is that ENERCALC does not design the tieback itself or its anchorage into the soil. So it only provides the user with the reaction that needs to be applied to that tieback for this assembly to remain stable. So the tieback and its anchorage shall be designed separately by the user outside of ENERCALC. So overall, shoring design is considered a specialty and is not something that a general practice engineer of record typically engage in. However, the SPRW module is a powerful tool that can expand the practice area of an EOR to allow them to enter this field of shoring design, or at least be able to run their own numbers, have a feel for what works, what doesn't work, and of course, back check or review the design of another engineer in case something was delegated and they just want an extra pair of eyes to look at it. So ENERCALC offers a wide variety of earth retention modules, and I encourage everyone to look into them and see how these options can help streamline your design process. So before we dive into today's Q&A, I'd like to encourage everyone to register for our office hours program to ensure that you receive notifications directly into to your inbox. So often our emails fall on deaf ears. Most of the time they end up with an IT department or maybe an admin managing the office software licenses, which means that these notifications never actually make it to the engineers who would benefit from these sessions. So to avoid missing out, I recommend that anyone interested in these monthly refresher office hours sessions to register on our website, and you'll receive updates directly to your email, and you can always unsubscribe if you need it, if you need to. So if you're interested, you can register by going to our website, enercalc.com/office hours. Or you can go to our website. If you don't want to use the URL directly, you can just go to our website, and which is enercalc.com, and then just go for our users page, click on get help/support, and then office hours live monthly education and Q&A. And from there, if you click on that, that'll take you to the registration page where you can put your information. If you don't know what your ENERCALC account number, you can leave that blank. Just enter an email and a name, and you can just click remind me for office hour sessions, and you will get emails from ENERCALC only about office hours. So you're not going to be getting any marketing or anything. It will be exactly for the thing that you subscribe to, which in this case is office hours. And of course, here as you scroll down a little bit, you see here always on our webpage, you will be able to see when the next session is going to be, what time, how to join. That's a link to join on Zoom. And of course, you can always add it to your calendar so you're always staying in the loop. And at that same page, enercalc.com/office hours webpage, you can we post all of the recordings of the office hour sessions, the previous ones that we did. So you can always just scroll down and find the previous session in case you missed this session, or you want a refresher, or maybe you want to send one of these recordings to maybe a new engineer who wants to learn how to design a steel beam. Then they can just go to the steel beam office hour session that we did a few months ago, and they can learn the ins and outs of how to use the steel beam module and so forth. I want to remind everyone that you will receive an email with a link to your PDF certificate within about a week, 10 days, something like that. So stay tuned and keep your eye on your inbox. And now it's time to open it for live Q&A from the audience.
All right, let's get into some questions here. So the first question from Joe relates to passive pressure distribution, the passive pressure reversal. And so the fundamental question is, wouldn't the passive pressure be calculated based on the depth starting from the top of the retained height rather than the top of the excavation? And then there's a kind of a follow-up question, wouldn't the active pressure on the soldier beam continue below the depth of the excavation? So a couple of thoughts on that, and there was a mention of the USS sheet pile design manual. There definitely are going to be some key differences between what Mac showed everybody today versus a true sheet pile wall where you have interlocking sheet segments, because this is a soldier pile and lagging wall with individual driven piles and lagging as opposed to the continual driven sheets. So there's definitely going to be some differences there. Now, when it comes to the pressure distribution, there's a number of different published models and theories out there for different pressure distributions. The specific pressure distribution diagram that ENERCALC is using does not take that backfill side or the back slope side active pressure and extend it below the foreslope elevation. There are a few models, especially for sheet pile walls, that do take that active pressure and extend it below the depth of excavation. But the particular diagram ENERCALC is using, which is shown in our help docs, does not. If you want to dig into that, you have more questions or want to discuss that with the support team, definitely send that to support@enercalc.com. That's just the current approach used by the module, and that technical basis that's in our docs hopefully sheds some light on that. I think second question here, Mac, did you have any thoughts on that? If you want to, go ahead.
No, that's exactly what you're saying is exactly right. No, I have nothing to add to that.
And there was an additional question about soil creep, sloped toe slopes, and seismic loading. Those would probably be more on the feature request side. You can, as Mac showed on the backfill side, you can apply a slope. We don't currently have any handling for the cut side, the toe side um, slope down there, and no handling for creep or seismic loading as far as I'm aware. Mac, go ahead if you have
That's
additional info on
that's
that.
correct. You're nailing it today. That's
Oh man,
absolutely correct.
I'm on it. Any plan to add Coulomb earth pressure design capabilities in addition to Rankine and EFP? So you saw as Mac went through, we had the toggle between Rankine and equivalent fluid pressure. If you have a need to do a Coulomb as opposed to a Rankine pressure, feel free to send that as a feature request to support at ENERCALC, and the engineering team will be able to discuss that with you. Question from Brett. If a pile is encased in concrete, should we say fully braced, or how to show lower section dot cantilever up is braced, no tiebacks used? Mac, did you want to go back to the discussion
Yeah,
about bracing versus not?
correct. Yes. So let me do this. So if you click on none, and that's what he's looking into. If we don't have any tiebacks at all, and this is encased in concrete, and regardless of what you use here, whether it's yes or no, if concrete is something which, obviously, if it's going to fully brace it, then you can just say, okay, consider pile fully braced for lateral torsional buckling, and you can just do that right here, and you'll be good to go from there. If you want to say it isn't, then it isn't. So you do have the option to do that, regardless of what you choose. The only extra option you get here is that if you do have a tieback, then you can kind of say the tieback is an intermediate support point that can reduce my unbraced length for lateral torsional buckling. So if you don't have any tiebacks, then your only options are you're either braced or you're not, and you do have the option to pick whichever you'd like.
All right.
Yeah, and I don't know if you
Next.
can see my screen here very well, but
Oh yeah, go ahead.
this our exact example right here. If you go with the first option that I chose, which is completely unbraced, give no concern, no special treatment with for the tie back or anything, just completely unbraced. That was given us 8.99 for the stress ratio for the fluxure. And if you say consider pile to be braced at tiebacks, you can see that that improved the ratio here to 0.85. And if you say fully braced, that is addressed right here all the way down to 0.64. So whatever you choose, you can do whatever you want.
All right.
And Seth, sorry,
Yeah.
I want to add one more thing because this is a good segue into this. So if you notice here in this new build of ENERCALC, we have a brand new tab in here. I didn't talk about this in the presentation, but there's a brand new tab right here that says Fluxural Detail. And what this does, this actually provides you intermediate, more information about the lateral torsional buckling. Right now, we have it implemented for HSS. So we're choosing here a W12 by 30. This part is not implemented yet. But if I flip to an HSS, let's say a W, I don't know, 8 by 8, and you click select, you actually have more information displayed that give you a good understanding of what's happening, rather than just reporting a maximum value for moment. Now you're getting more of the little intermediate values and how we came up with this. So obviously the part where we do this with HSS, it has already been implemented, and that was implemented in this round of updates. But the W section hasn't been implemented, and that's why I didn't really mention it this time. We wanted to mention in the presentation when it's fully done. But at least for HSS, it's definitely done. For W sections, it's under construction. It'll be happening at some point.
All right. Next question from Brett. Is it possible to add in vertical bearing load offset behind the shoring, say building foundation 10 feet behind the shoring wall? You talked a little bit about surcharge, Mac, but
Yeah, that's a feature request. because it looks like he's asking for it to be
An
more of a
offset surcharge,
concentrated load and
basically.
offset. Yes.
Yeah. Yeah.
This
So you
one,
do
yeah,
have
this
the
one
capability
doesn't.
for surcharge right now. You just can't offset it to an arbitrary distance in the backfill zone. So definitely reach out to the support team if that's a feature you'd like to see integrated.
And the same
Uh,
thing if you want it to be a particular point load. That's
mhm.
also another.
Yeah.
Yeah.
Question from Dan. Do you mind going over the lagging tab? There's not a lot of information there. It's mostly labeling information more so than design information.
Correct. Yeah. This is what it does is that you can choose the lagging depth. So, it depends on which lagging you're looking into. The one all the way down by, 5, 6 feet below the retained soil, or the one that's only 3 feet below the retained soil. So you can kind of put lagging depth here, and this will do some calculations to tell you kind of what kind of moment and pressure and shear, but this does not design your lagging for you. You have to go and design lagging separately outside. And this is, again, this is just kind of to give you a good idea. Hey, this is the analysis. This is how much load you have. You need to go outside, design your lagging. Maybe your lagging is 2 by 10. Then you come right here and you say, 2 by 10, you say it manually, and it will just provide it for documentation, but it does not design it. So that's why I don't like to go over this, because I want to make sure that you're not getting fooled into this designing. This is not designing. This is just telling you what's the applied load on your lagging. If your lagging is placed 6 feet below the retained soil, then you need to take that moment and that shear and all that stuff, go design your lagging somewhere else, and then come back right here and say, okay, a 2 by 10 works or whatever, and that will be included for documentation perspective in case somebody's reviewing your calculations.
All right. Next question. Is tieback angle considered in the sheet pile calculation? Again, not to beat a dead horse, but I do want to make sure everybody's clear that we are talking about soldier pile and lagging, not continuous sheet wall, since there's some subtle differences there. But the module does not have an input for the inclination of the tiebacks. It's basically modeled using a horizontal reaction point, and so you would have to, if you had inclined tiebacks, you would have to take the inclination that you're going to use and use that to appropriately magnify whatever is the vector of the inclination of your tieback. Hopefully that answers the question.
Yeah, that's absolutely right. Now, when I get back to this, yeah, this is what we're designing. So those are not sheet piles. We're designing just certain, pieces at 6 feet, 8 feet on center, and then you're doing lagging in between. So this is not sheet piles.
All right. Next question. I'm following the example with the software that we have. The tab for construction sketch and wall loading sketch are the same sketch. Both tabs show construction. So there's a minor display bug that the team is working there with displaying the wall loading sketch in some cases. So that's a known issue, and there will be a fix upcoming for that. So good question on that. Next question. I can't toggle between Rankine and equivalent fluid pressure. So that's probably because you have tiebacks activated. Once you
Yes.
activate the tiebacks, like Mac was saying, that throws you into a completely different analysis approach. So instead of using the continuity of the soldier beam into the soil, activating additional pressures below the excavation grade, instead we're now using those tiebacks to create stability for the wall. So it's a completely different analysis. Mac, go ahead if you
That's
want to
absolutely correct. Yeah. So
elaborate.
if you choose any tieback, then these are out of, those are no longer what we use. And this right here that says soil pressure reference, this what gets used. So if you have a single tieback, so this is TH1, that's, for example, the tieback location at height 1, that's what gets used. If you have multiple tiebacks, then the equation boils down to this, which is, TH1, TH2, TH3, and each one has their own height, and it's all done, for n, so it doesn't matter how many you have. So that's more of the generalized equation. So if you have a tieback, this is not getting used, and what's being used is the soil pressure reference right here. Now, if you go back to clicking none, so no tiebacks whatsoever, then you can come back right here. You can toggle back and forth and use whatever information you need to use, or input whatever information you need.
All right. Next question is kind of related to some of our questions about tiebacks. Can you add the design of the tieback? And so that would fall more in the feature request realm right now. If that's something that you guys have need for, go ahead and send that to the support team, and that'll kind of go on the pile of feature requests so that the engineering team can direct those development priorities. Another interesting question: how are you planning to implement AI into ENERCALC? For those of you who don't know, you already have some AI capabilities for getting help and support. We've talked about that once or twice in previous customer sessions. The ENERCALC engineering team is growing and larger than it's ever been, but on your nights and weekends and holidays where you need support fast and you can't get a human response, you can go to enercalc.com or enercalc.ai. You can navigate directly and get our chatbot, which is like a GPT style um, AI trained on our ENERCALC documentation. Ask wayfinding questions like, hey, where do I find updates and installers? And technical questions like, how does the module do, such and such technical tasks? So you have all those capabilities. That's a support oriented thing. As far as engineering design oriented capabilities, we're interested in hearing from our customers. If you guys have a use case where you say, hey, what if we could use machine learning or AI or data analysis to do fill in the blank, definitely reach out to us with those questions or comments. And here Mac is
It's
showing you
a Yeah.
the
So if you
AI.
go intercalc.ai, you get this page, and I'd literally just type, the name of our AI is Jack. So I talked to Jack. I was like, hey, does the steel beam module check lateral torsional buckling failure mode? And then it's answering here, yes, the steel beam module, does this or does consider lateral torsional buckling failure. However, the axial. So it gives you some information. Of course, this is not an engineer, but this helps you a little bit to get ahead. Like, does intercalc um, implement IBC 2024, something like that. So you can have some questions like this, and then if it knows what you're talking about, then it'll say yes. If it doesn't, then it'll tell you go talk to support. This is definitely not a replacement for support or anything, but it might take you to the right place or to the right FAQ or to the right user manual entry that we have that can help you navigate or answer some of your questions.
All right. And our last question for sloping backfill: is the equivalent fluid weight option entered the value for a 2-to-1 slope, or do we use equivalent fluid pressure for a level back slope and assume the software calculates the additional surcharge from the slope angle? That might be a question for support to dive in your specific case. But Mac, go ahead if you have thoughts about that.
Or slope backfill is equivalent for a pressure weight option entered the value for it. Yeah, I'll have to look into the user manual for this. I'm not sure, to be honest. I'll have to dig into it.
Yeah, but we can definitely get back to you on that, or you can fire an email over to the support team. Well, that is our last question. Mac, do you want to kind of close us out with a teaser for next month, date and possible topic?
Yes, I think the next month session is going to be July 9th. We're still fiddling with a couple of topics, but this might be the one, but we'll see. But it looks like it might be the cantilevered retaining wall, but we will confirm this next week when we send out the thank you email.
All right, outstanding. Well, thank you everyone very much for your time. We always look forward to seeing everybody here every month. Again, if there's ever a question that we didn't get answered for you, or you'd like to dive deep and explore something technical under the hood of the program with the support team, definitely follow up to us with an email. You can reach Mac with questions or suggestions for future topics at the office hours at intercalc.com. And of course, the support team is support@intercalc.com. From there, we'll look forward to seeing everybody next month. And thank you all for being here.
Here.